Hello, my name is Mitchell Strapinchik. I am the manager, you could say, of the Chicago Clojure Meetup. I'm here on Zoom with my friend and former colleague, Toby. Hi, Toby.
Hello.
And we are going to be giving a talk, which I will share my screen now, so stand by. In fact, can folks see my screen? Toby, can you see my screen?
I can now,
Great.
yes.
All right. And then I need to, let's see, this is where I could just, no, go back, go back. There we go. Okay. Can I make this, uh, trying to remember how you jump into this.
I think there's a presentation button on the upper left
You're probably right.
next to the save icon and those two arrows.
Yeah, no, back,
Up more.
up more, home, slideshow. There we go. From beginning. Ha,
There
there
we
we go.
go.
Okay. So let me just hide that. Good. Okay, we will go ahead and begin. The topic of this talk is an echo of a presentation I had given back in 2018 at the Chicago Clojure Meetup when took place at the headquarters of Guaranteed Rate offices in downtown Chicago. In this, it is how I use Clojure to appear at long last on the National Public Radio Sunday Puzzle. The topic, the presentation, and I don't need to annotate. I need to move to the next screen. How do we do that? And this is where I'm pushing the wrong button. That's why. The keyboard I'm using here is a little different from what I'm used to. So there we go.
Mm.
Okay. Yes. This presentation is divided in more or less broadly into 5 parts. A review regarding the NPR Sunday Puzzle, how it works and how I got on. Uh, it involves solving a puzzle, which I will sometimes use a computer program that I will write to do that. There were 2 key components necessary for this to work. One was I wound up translating into Clojure some old code, very old code, going back almost a quarter century, which we'll discuss, as well as an even older reference, which we'll also discuss. In fact, I actually have a copy of it here, but we'll discuss that as well. How I combined the two to create a solution in Clojure to solve the puzzle, and I got lucky. It turns out that I submitted the solution with the result of that solution that I wrote in Clojure. I got picked to appear on National Public Radio 3 years ago this month. It was May 14, 2023, we'll talk more about that as well in a little bit. I have a little bit of an advertisement for this. One is that I am paying for the fees to meet up for the Clojure Meetup out of my own pocket. If you can, donations would be very much appreciated. I can accept money on Venmo or Zelle or probably other things. That's my contact information there. Also, secondly, speaking of money, I am currently out of a full-time job, and I am currently looking for a new full-time job. If you have any job leads or know of any job leads, please let me know. You can reach out to me at my email address there or other communications channels. I am on some of the socials, Instagram, LinkedIn, Facebook, and also my website at szcz.org has contact information there. A little bit of review regarding the NPR Sunday Puzzle. Every morning, every Sunday morning at 9:40 in the morning Central Time, during weekend editions, the program that they have on National Public Radio on Saturday and Sunday mornings, they have a puzzle that Will Shorts, who is the main puzzle editor and main crossword editor of the New York Times, and has been since 1993, goes back that far. He is also the puzzle master of NPR, and he presents a weekly puzzle for some lucky person to play. And to find who that lucky person to play is, they provide another puzzle for people to try to solve on their own at home, at which point then they can go to the NPR website to submit and then hope that if you're correct, you could be put into a drawing where you would get selected to appear on that next week's show. That's actually how I appeared, and we'll talk more about that in a bit. But that's in a nutshell how that works. I'd been listening to the NPR Sunday Puzzle since I discovered it in 2006. But since 2013, had been solving it and using my favorite programming language and current programming language of choice, Clojure, to get to solve some of these puzzles. I had done so many that I had uh, compiled some of the um, solutions that I had written in Clojure as a presentation that I gave at the Chicago Clojure Meetup, as you will see here on this screen grab back in December 2018. I recorded the video of that presentation, which is then as now still online if you would like to revisit the magic of that presentation that time, where I talk about that and solutions and various neat tricks, both in coding and in language and other interesting things to solve puzzles. Um, uh, Most of the puzzles that I had solved still live in a puzzle repository that I put on GitHub, named NPR Sunday Puzzle Solutions, where all of the attempts in all the various languages that I've done over the years are um, uh, uh, are included here. So you can see the attempts, and it actually was useful for reminding me what I did 3 years ago for the solution for the attempt when I finally got on. I'd been doing the puzzles pretty dutifully, more or less on a weekly basis, 4 years. And it was on the presentation, it was the puzzle on May 7th, 2023, that they posited this puzzle. Think of part of the human body whose name is a compound word like fingertip or toenail. Add an N as in November, and rearrange the results to get another part of the body whose name is also a compound word. What body parts are these? I took the challenge on and I solved it with two tools. The first one was a tool that was the result of actually a challenge my sister actually posed to me, where she once asked me, in fact, you can actually see the story here where I read that. In fact, I'll read it here. In December 2001, I received an email from my sister who teaches English to fifth and sixth grades. She now has graduated and she now teaches sixth through eighth grade. She emailed me to say that she gave her class the assignment to make as many words as possible from the letters in the word representative. And they asked me if I knew any web pages that could automatically make a list of such sub-anagrams. After a search of the web at the time, I was unable to find such a page. But I work in IT and I study computer science, so I wrote such a web page. Here it is. In fact, this original code was written as a CGI script in Perl. Here is a little excerpt of the source code in Perl that I put in a CGI bin directory on a server I had access to, where people could take a form and then actually would call that CGI bin directory, which would access the list of dictionaries, looping through it, and then tracking both the letter frequencies within the word that you're submitting, as well as the word frequencies within each word in the dictionary itself, comparing the two to see if you then have enough letters in the bank for each word for that letter to see if it would appear, basically for which you would have a sub-anagram. That's basically the algorithm in broad strokes. This was how I originally wrote it in Perl back in the day. I later wrote it as another CGI bin script in Python, which I later put on my website. But I also made a variant where I rewrote it yet again in Clojure script. In fact, this is the repository of the Clojure script repository of the Clojure script source code, where I converted the code into Clojure, then brought it into Clojure script, then compiled into JavaScript, and then made that available on the web through a web form, so that it does the same thing much more quickly, and it was a lot more fun to write. So anyway, I've got this, and this is actually still also online if anyone is interested. The source code for this proved to be helpful, ultimately in Clojure for the solution that we'll review in a moment. But there was also another resource an older reference, in addition to old code, that was critical for solving this. Toby, have you ever heard of the Random House word menu?
I have not.
Yeah, this is a word single volume reference that was published in 1992. In fact, right now, as I'm speaking, I am holding a copy in my hand. I still have a copy. I actually bought it in my first year of college that same year, and I still have it. It is a This is different than a thesaurus in that, unlike a thesaurus, which lists out synonyms, lists out, and this is where it comes in handy. If you want to know, like, for example, kinds of hats, you can just go through the word menu and find out lists of hats. And also, if you're looking for a particular kind of hat, you can just browse through the list and find the particular hat that you're looking for. This was handy because it turns out that they have multiple lists of body parts, which I actually compiled, and I actually looked through the code repository over the course of 6 code commits, the last of which was in 2021. I had gone through the word menu and put them into a file because body parts, turns out, are used as a occasional thing that they ask on the NPR Sunday Puzzle. So I thought, let's put them in. And over the course of, it turns out, first commit was in 2018. The last was in 2021. 6 commits over 3 years, where I basically steadily built up an online file of body parts. It wound up being 673 words that were ultimately in this file by the time I used it for the solution here. And how did I use it? As follows. Once I had a file that I called, look at, Clojure at long last in the Chicago Clojure Meetup. Once I had a file that I called body parts, which I put in the resources directory, I then slurped that to get the data from that file into local memory, then ran a split lines function so that each line in the file was a single entity in a Clojure collection, and then applying with the map v function to create a vector, a function called cleanup word, whose source code you can see at the top of this the function there. And it's pretty simple. You just basically take a word, turn it into lowercase, and remove anything that is not a lowercase letter. All the words I had put into the file were lowercase, but there were the occasional space and the occasional dash and a handful of other characters that would sometimes crop up. This function just simply said, take each word, make sure it's lowercase, and remove anything that is not a lowercase letter, and just simply make that available as a variable that we've named body parts. So that was the use of the word menu to be able to solve this as part 1 of the solution here in Clojure. Part 2 involves a rewrite of the sub-anagram generator in Clojure as a single function, and here it is. Your 2 words that are brought to bear as inputs, which I've named base and compare. And you're basically taking the frequencies of that using the frequencies function. With the compare frequencies, you're just simply using frequencies on compare to get back a map of the frequencies. A key value store where each key is a letter and the value is the number of times that letter appears in that word. Base frequencies is just simply taking a creating a map from all the letters in the English alphabet, combining them with a list of zeros, making a map out of that, and then adding in the frequencies of that base. And then you're doing a straight out comparison for each of the letters, each of the keys, the letters, that is, individual letters and compare frequencies. Do you have enough letters in the compare value that are where there are enough in the base value, the base frequencies? So you're just using the every function as a straight out comparison, using this intermediary function, an anonymous function, actually. And you're just comparing each of the compare frequencies with the base frequencies of the values in each of those Clojure maps, and making sure that there's a value that at least there are at least enough values in the compare as there are in the base. And if there are, you count that as that counts as a sub-anagram. And then, what the heck? There we go. And then getting the answer with this function using a list comprehension, a for loop. You're going through that list of body parts that we had created earlier, and then using both the len and the whet. The len statement uses a filter function that assigns the results to the value that we've defined as f, where for each of the body parts, you're comparing each body part to a subanagram of each other body part, and checking to see if not only is it subanagram, but is that subanagram exactly one character smaller than that subanagram? Because remember, we're adding in an n. Now, I could have rewritten this to specifically check for an n, but this was my first take at arriving at a solution, and it turned out, as you will see momentarily, it worked just as well. We assigned that result into F to determine back the list of one character off subanagrams, but only listing out whenever there was something in that list of subanagrams. That's the when statement, which for some reason I include in a superfluous and. You're just checking to see if the value is not empty. Actually, now that I think about it, I could remove the and I could replace the not empty with a seek statement. But, well, it did the job. And in fact, the job and the results of this function and the previous functions was this. This is the result of the output of answer when you actually run that list of 673 words through that map. And the result is 29 entries. And then using the Mark 1 eyeball of just looking through it to see if I could find one that matched, I did. And you can actually see it highlighted. Underarm and eardrum turn out to be subanagrams, one character off subanagrams with an N involved and involving compound words: underarm, eardrum. So I submitted that in. I got like, huzzah, I got the answer. And I submitted that in. And then it was that Thursday. No, it was not on a Wednesday. It was actually on the Thursday night when I actually got the phone call from Gabriel, a producer at NPR. He actually called me. I had just finished work, and he called me to say, "Congratulations, you've been chosen to be on NPR. Can you be available tomorrow morning for a phone call with Will Shortz and with Aisha Roscoe, who's the host of NPR's Weekend Edition on Sundays?" And I said yes. And we had a very interesting phone call that ran for about 20 minutes. I documented it on my website. And it went very well. And that Sunday, May 14, 2023, which happened to be Mother's Day, it turns out that this is the page where you can go to listen to me and Will and Aisha play a game for about 5 minutes, where it turns out that we had actually talked for about 20 minutes, but they cut a lot out. But you can actually see here this challenge. My proposed answer was indeed correct, involving eardrum and an arm. And there's my name. I got picked, and I got to play on the radio, and a lot of people heard me, and I got a lot of shout outs, and that was really fun. And I also wound up getting a lot of prizes in the subsequent months, which I also document on my website. And in fact, here are the links to all of the foregoing. At the top is the link to my the post on my website where I talk about the adventure, and also a lot of what we talked about in the time that we were on, that we actually recorded it, because it's not broadcast live. It's actually recorded about 2 or 3 days in advance and then edited for time and editing considerations, and then later broadcast that Sunday. As well as my GitHub repository with the both subanagram CLJS for the Clojure script equivalent of the subanagram generator, and the repository also online for the list of NPR Sunday puzzle solutions going back since 2013 was the first I had actually solved that. So it was actually 10 years worth of attempts in trying to get on NPR and in solving puzzles using computers, where finally succeeded in 2023. And then the link to the actual broadcast page of my appearance back on May 14, 2023, Mother's Day, where you can relive the magic and hear me play a game and do pretty well. The puzzle I had to solve involved subanagrams of animals. But yeah, so ta-da, that's how I use Clojure to appear on the NPR Sunday Puzzle. Thank you. And yeah, Toby, any questions?
No, that's good. Thanks.
Thank you. Any questions?
Nope.
No? Okay. Cool. Okay. So I'll go ahead and was there anything else?
No.
No. Okay. So yeah, I'll record. I've been recording this. I'll stop the recording and post it online in the next day or two and share that with the Chicago Clojure Meetup. And yeah, I guess we'll just end it there. Um, anything else? I guess we'll end it there if there's nothing else.
All right.
Okay. We'll end it here. Thank you very much for taking part. And yeah, we'll see you around.
All right. Take it easy.
You too. Bye.